Hi, everyone. Just a minute here. While I was setting up the meeting, my computer straight crashed. So we'll be doing this today from the iPad. So give me just a moment to get on here. Let's see how this goes.
Do you know what the problem is for your PC?
Yeah, I tried to reboot. I was cleaning up some applications earlier, and I came back after an hour in the living room to my PC, rebooted and on a Windows blue screen. Apparently, somehow my boot. This meeting is being recorded. Sorry. Just okay. There we go. No more echo. Yeah, no, I was just some programs came back to it, and apparently my boot partition is just gone, and I don't know how. So I'll have to resolve it later today, but it takes a little bit to fix. Anyway, let's see if I can share this on the iPad. Okay. Let's see if y'all can see this now. Okay. Not as scuffed as I thought it would be. Nice. Okay. So I have a couple things on the agenda for today, talking about robotics and game theory, but I also had gotten a couple emails for people asking about the research experience for undergraduates and independent studies and whatnot. So I am going to go over that first. Generally, the question is, how do you get into undergrad research? And there are two main ways that undergrad research are conducted that is actually on the books. So the first is through independent studies. So for your, let's see if I can find, grab the graduate students. Degree programs, BS and CS requirements. Okay. So for your major requirements, right, you are required to have, I believe it's 8 upper level, CS courses, right? Of those, only 2 of them are fulfilled by courses that you are required to take. So one of those is 311, and the other one is going to be 320 or 326, which is either software engineering or web programming. So then that leaves 6 other 300 plus courses. Now, one of these can be an approved outside elective, right? And that is, these are the standard ones that people normally would ask about, but there are others that are also not here. And it's really taken on a case-by-case basis. If you feel like something should count, then you can ask. And then typically they'll say either yes or no, or they will ask you for more information about the class, like, well, what's the syllabus? What kind of things overlap? What's CS content? Stuff like that. But regardless, there's some math classes here like abstract algebra, combinatorics, and real analysis, of which, theory stuff would be it's more like applicable to theory stuff and some algorithms. And then there's ECE, which is more on the electrical engineering side. And so those are probably going to be related to lower level systems things, or maybe some computer engineering things. But there is one here, right, statement here that you can get up to 3 credits for 396 or 496. And there's also the 499 T and P, which are the honors theses and project stuff. But 396 and 496 are basically independent studies. And so what that means is that you can then have just 5 requirements if you do the 6th being an independent study. So what the independent study is basically a 3-credit class that you take as a class, right? But it only is done with just you and some professor one-on-one, right? So the most typical uses, right? There are 2 typical uses. So the first is for a class requirement, or sorry, not a class. The first is in lieu of a class, right? So say that you want to take a 600 level course and they're not able to override you into it, maybe because you're a newer student, or you have it's like enrollment that's too close to the deadline or something like that. And so they're unable to put you in the 600 class for whatever administrative blocks, right? Then in that case, they would just put you in the independent study. You would do the content the same as a 600 level class. You would go attend it. You would basically be a student 600 level class, be treated the same. But just on paper, you would have that independent study listed. And then wherever relevant, you would list, well, this wasn't actually an independent study, it was this grad class. And on your transcript, you could just note that, right? And I believe they do note that if you had a study on your transcript. But the second, and I had a friend who did that as well, who did that for a grad programming languages class. But the second use of independent study, and the much more common one, is for research. So typically what would happen, see, let's I don't know if it's listed on the course offering guide or not. Okay. Well, typically what would happen is you would find a professor who you want to do research with, and then they would basically get a form. Here. Yeah. So you would just have this form that you would fill out. There's also an in-person paper one. And then it would be given to the CS administration, and then they would enroll you in the course. They override enroll you in the course. And this is, you basically have to describe what is being done for whatever independent study. So most commonly, this is for undergrad research for, say, you want to work one-on-one with the professor on a research project, or you're being included on a research project with another set of grad students or something, then that's what an independent study would be used for, and you'll get credit for it. Now, the second method of doing research that's not an independent study but still on the books is the NSF research experience for undergraduates, right? And the research experience for undergraduates is basically funded by the National Science Foundation for only US citizens. So note that you have to be a US citizen or permanent resident. If not, you can still do the independent study. But you get a stipend that I think is equivalent. I think it's still $2,000 a month in the summer, so it's not high. But you would get a stipend to basically do the same research you would do in an independent study, just that you're doing it for now money in the summer instead of credit during the semester. Right, that's really the only difference. Getting approved for it is similar process to the independent study. So what happens is RU funds are allotted to programs, and then it's given to professors who want to do research with the student. So it's no cost to the professor to do it. They're not funding you, the NSF is. And so our program usually ends up having excess funds, which means that it's usually pretty easy to get an RU with us. The second thing to note about RU is that it actually is not just for UMass, right? Like every institution that's a publicly funded institution in the US, and then a lot of private ones as well, that have like research programs, they will have RU sites, right? And so you can use the NSF website and you can actually search for these. If you would like to do an RU somewhere else, then there are a bunch of options, and you can just contact and try to apply to these to be able to do research elsewhere for a summer. So for example, I had a friend who did this at Brown University, right? Now, not all the places list up here, and like UMass isn't listed on here. But if you do find something that is interesting, then you can potentially go to work there. So for an example, right, Carnegie Mellon is the best known university for machine learning and artificial intelligence research by like miles of other places, like more than double, right? The second place basically in terms of research output. And so an example here is that they have a place here in robotics to work on artificial intelligence or robotics stuff, right? And so you could look into this position here, see what the project is about, and then potentially get in contact and see if they're still looking for people to work on. Now this ends in like 2021 of May, so maybe you wouldn't be able to do this in the summer for next summer, but this is just an example. Like there are plenty. Now I don't know how this is going to adjust with COVID, how they're changing these stuff, but it should still be doable at multiple places, and I don't think that UMass is going to be impacted for doing work here. Okay. So as per finding who to do research with, that's one of the harder parts. And I'm going to check chat every so often because it closes my camera once I check chat. So for finding a professor to do research with, there's a couple of methods that I would recommend. So the first is to check for new faculty, right? Let's see where the news is here. So if you just go to the UMass CS news, then you'll be able to see when there's new faculty. There was one announcement pretty recently. Here. So here's this one where the CICS announces the hiring of 12 new faculty in 2020, right? So this is not faculty all going to be starting in 2020, but most of them will be, or will have, at least in the fall. Plenty of them will also start next spring or sometime next year. But most of these people are going to be new to being a professor, right? Like they're not all being hired as, they're not all being hired from other places, right? Like a good amount of these are just completing their PhDs now, right? And what does that mean? That means they need students, right? They are going to want to have students to increase research output to be able to show that they contribute to the university, right? They want to be tenured, right? They want to have tenure. And so in order to establish themselves, not just the university, but in the field, right? You need to have people who do research under you. And so honestly, like one of the best ways is to see if your research interests align, or not necessarily that you have research interests yet, but if you think you might be interested in working on something on this list, right? Go and check them out and see if they're doing a talk sometime, right? Send them an email, whatever, attend one of their talks and then talk to them afterwards, something like that, right? So a good example, right, is this person here, right, Hamid. So he actually got his PhD here from UMass, right? And he's a very smart guy, and he's coming back to start as an assistant professor, right? He started this fall. And so I'm sure that if you went to look him up and you like what he does, his work with machine learning or whatever recommendation systems, then that might be interesting to work on. Here, there's someone who does machine learning and natural language processing work. This person does computational biology, right? This person here does security, right? So there's a wide variety of faculty coming in that all are going to be looking to have research assistants, and not just grad assistants, but also undergrad assistants, right? Through independent studies or RUs. So definitely do check those out. Those are typically the easiest routes to say, because that's going to be the people who are most looking for undergrads. The second thing is through courses. So if you go check out the courses and you find some course that, or you're taking some course that has a faculty member who does research that you like, then that's a much easier in, right? Because you already have a connection to them. You can go to their office hours, whatever else, and talk to them. And it's also important to note when you, was already spring 2020, 2020. It is important to note that typically when you go up to talk to these professors, right, and to ask them to do research or whatever, usually the first question you're going to get is, great, have you taken my course? And by their course, they're going to mean some, or they're going to ask if you've taken some undergrad course that's offered in their field, right? And if you're wanting to start this early, then clearly you haven't yet. And so just make sure that you have like a plan as per whether you're going to take that course or not, or when, or if you're going to try to learn the relevant information on your own, or whatever else, right? Or what kinds of programming experience you have, because more often than not, you'll be able to do some sort of independent study where you collaborate with a professor and a grad student, and then you'll be doing like the engineering work for the grad student, right? Like you'll program up the code that will get whatever data or do whatever the grad student, says the code should do. So there's definitely stuff like that that you're able to do for independent studies, but just make sure that you're able to have a plan or explain how you have or how you plan to get whatever information is required to do work in this area, right? Foundational information. They don't expect you to be experts, right? But they do expect that if you're trying to go work, on research and machine learning, that you do know how to program, right? In say Python, right? And that you at least have basics in statistics and probability, for example. The next space to look is you can look at the research labs that are offered here. So if you go into the research section, we have listed here, this isn't all of them, but we have a bunch of research centers and labs. And these will have the faculty listed as well with descriptions. And so you can find research labs that sound interesting. And then you can check out the faculty members and see if any of them have it listed on the webpage, whether they're taking students or not, or whatever else, right? So an example would be, let's say you're interested in data mining stuff into fraud detection. Okay, that sounds pretty cool. So David's a good guy. I could go check out his webpage and maybe he'll have it listed. Let's see, he has students. Let's see, looks like he has a bunch of grad students. And okay, so it doesn't have it. So some faculty will have like listed, if someone wants to work with me, I'm open to it right now, to send me an email or something like that. So he doesn't have anything about it. So what I would then do in that case is, check out what he teaches, see if it's something you're able to take. So these looks like there's a principles of data science course. So maybe that would be good to take. And then, talk to him, say, hey, I'm in this course, or hey, I've taken this course. I'm really interested in what you do. I'd like to, do an independent study. And he'd probably be more than happy to do it. And if you don't want to like take the course ahead of time, you know, before like investing into that to say, then you could send them an email, say, hey, I wanted to kind of do work with you. I'm thinking about taking this course. Would you be able to do an independent study like a year from now, right? Or like next semester, right? Those are definitely all options. And then I would also recommend looking at listings. So this is, again, this is kind of like what you'll find on people's web pages, but also look out for emails, because oftentimes if faculty are looking for researchers and undergrad researchers and they haven't found anyone yet or nobody's talked to them, then they'll just ask the department to send out an email, or they'll send out an email themselves. So just kind of like, check in at your email, and you should get an email if they're interested. And the last and one that's probably the most important is talks. And I've mentioned this before, but really use the events calendar to look for CS faculty who are doing talks, and then just go attend their talk and pay attention, ask them questions at the end when they have questions that are, when they're asking for questions, and then talk to them, right? Say, hey, I really liked your your talk. I like your work. Have some background knowledge here, but I'd like to look at doing some research here. Can we talk further about this or whatever? Okay. An example. Let's see. I think this. I think there was one on the first. Go here. I'm just holding down to try and see if there's one that's like a CS UMass web page. I think this one. Okay. I can't find the one that I was referencing earlier today, but there will be plenty that are done by UMass faculty. And so you can just, find one, and then if it sounds remotely interesting, you can attend and just talk to them afterwards. Oh, here, yeah, like Dan Cohen, right? Like this is someone at UMass. So see if you like the talk that they give, and then, talk to them afterwards. So those are what I would say are good to look into. And I think that the new faculty route is very promising, as that's typically where people find whoever to do research with honors theses and stuff, if you have to do an honors thesis. Yeah, so if anyone has any questions about that, feel free to ask or email or whatnot. But now I'm going to talk about game theory. So, so game theory is really a bit of a misnomer compared to what it used to be. I'm going to pull up the course listing as well. So game theory used to be, back in roughly the 30s and 40s, it was about zero-sum games. And what a zero-sum game is it's basically a game where if you sum up all of the gains and losses of participants, then you'll get zero, right? It's kind of like you're taking pieces of a pie, or, if you have points and you take points from someone else, like they lose the points, you gain the same amount, right? Like you don't just like lose anything to the ether, right? And now it's evolved from really how to play those games like optimally to anything related to logical decision making, right? That's kind of really what game theory is about now. It's about rational agents making decisions. And that might sound familiar if you remember from when we talked about AI, because it is, right? Game theory is really a foundational part now of artificial intelligence. Okay. A good example of game theory is the prisoner's dilemma. Right? So the idea, actually, let's see if I can do this here. This is not going to be scuffed at all. Yeah, boy. Okay. So the idea for game theory, right, is that you have here. So, so the idea for prisoner's dilemma. Prisoner's dilemma, right? Maybe you can see this hopefully. Yeah. So the idea for prisoner's dilemma is that you have two people, right? Maybe we'll call them like Bob and Alice. Those are the typical two names used in explaining computer science problems. So Bob and Alice were both convicted of a crime, right? And they've both been taken in for questioning. And they're being questioned in two separate rooms. So let's put like two separate boxes, right? And both of them are given a deal, the same deal, right? The same plea deal. And the deal is, right, you can either confess, right? So you can A, confess, or you can B, you can stay silent, right? So you can stay silent, right? You don't have to confess. But if you confess to this, right, I'll start going over here. If you confess to this, then so put like, so if you confess and the other one doesn't, so we'll put like, so put, so if one of them confesses and the other one doesn't, right, then the confessor will get, we'll say 10 years in prison, and the one who didn't confess, who stayed silent, will get 30 years in prison, right? Long time in prison. However, if both of you confess, right, you'll both get 30 years. And if neither confess, right, so if both stay silent, then you'll both get 15 years, right? So this is the prisoner's dilemma. And it's called this, right, because if you're a rational agent, then what you would think to do is you would either think to confess if you believe that the other person is not going to confess, because then you'll only spend 10 years. Or sorry, you would confess if you think the other person is not going to, yeah, and then you'd only spend 10 years in prison. Or you would not confess if you think the other person is not going to stay silent, and you'd spend 15 years, right? You'd both spend 15. Now, between those two choices, right, if you're between 10 and 15 years, right, you'd obviously choose 10, in which case it makes sense to confess if you can guarantee the other person won't. But the problem is that the other person has the same deal as you, right? They're also wanting to behave rationally. They're doing the same deal as you. And so they're thinking the same thing, right? So by this logic, then both of them may end up confessing, in which case they spend 30 years. But if they can trust that neither one of them will confess, right? If they trust like 100% certainty, then neither of them will confess and they get 15 years, right? And this is the dilemma, because you don't know what the other person is going to pick. The optimal choice is clearly to end up with both this, right? It results in the total least amount of years, right? So this would be 30 years total spent. This would be 60 years total spent, and this would be 40 years total spent, right? So it clearly this is the best choice to minimize the amount of years spent in prison. but you can't guarantee that what the other person will do, right? Because they're also trying to just minimize the amount of time they spend in prison, right? And that is the notion behind the prisoner's dilemma. Yeah, if both confess. You can use any number of years that you want. I'm just using this 10, 30, 30, and 15 example. But yeah, typically it's gone with like 10 and 20. So, but really it works out to be the same concept. So it doesn't really matter. So that's the prisoner's dilemma. And it's really shown as like a foundational part of game theory now compared to what it used to be, because it's not zero sum, and the the prisoner's dilemma was really introduced, I think, around about the 60s, and it's the first introduction that you usually have in the CS program here to game theory is prisoner's dilemma, usually in 250 or 240, sometimes both. And the reason that I bring it up is because it is, again, foundational to AI. Now, with game theory, show my screen again. Start podcast. Okay. So with game theory, we do cover this in 383 as well, being, the undergrad artificial intelligence course. And, since it's really foundational, that's really included in this like game playing, logical reasoning, and decision theory portions. Okay. Decision theory, and that's sort of game theory, right? That's what that encompasses. And I'm going to pair this with robotics, right? Because game theory, robotics, and AI are sort of all interrelated right now. And this really hasn't been the case historically. But in the past, 20 or 30 years, that's really become the case. And it's going to continue to be the case for the next at least 30 to 40 years, but probably, for the rest of time for robotics and AI, because as we've developed more complex robotic systems, as we, robotics goes back a long way, right? You have like contraptions, developed by Leonardo da Vinci, right? That, like flying machines and stuff. And those are all supposed to be kind of, resembling robotics, right? But until recently, we haven't had the ability to just generally program robots, right? We haven't had the ability to have a general purpose robot or some, robot, and then be able to program it to act on its own, right? Autonomous is what that's called. An example, right, is, we have these nice, mechanical arms that we're able to use to work machinery in factories. So search factory some arms. Right. So an example is these industrial robots at car plants, right, is usually the biggest example of how this is how cars are primarily assembled now. Like there's just these general purpose arms that have different attachments on the end, and they're just programmed to do one task repetitively, right? And that's sort of where robotics is, and still where it's going to be heading, except that what they do specifically is going to be expanded by the advancements in AI, right? You could consider these things to be, kind of like AI that are very narrow AI, right? But a better example, right, is, for example, self-driving cars. Those are narrow AI. They're AI developed with one specific purpose. They're not general purpose. We're not going to have that for a long time. But they're generally, smaller, narrow AIs that have the ability to control a car, right, being like a robot. Same thing for healthcare, for example, right? You want to be able to develop robots that are able to perform surgery, right? Or robots that can augment surgeons to be able to perform surgery, or maybe robots that are able to help, care in elderly homes, right? All of this is really where robotics kind of heading, is to integrating artificial intelligence. So that being said, what it ends up being usually a cross-discipline, right? Robotics involves people from electrical engineering. It involves computer engineers. Right? It involves people from whatever field you're applying this to, whether it's, you're applying it in healthcare, maybe you're going to have medical professionals, maybe you have biologists, right? If you're applying this to make some sort of humanoid robot that's supposed to interact with people, then you're going to do, work with biologists, right? To be able to determine, lower level muscle structure and stuff. You might do work with nutritionists to make sure the body type looks right. You make sure that it doesn't reach that uncanny valley state, right? You might work with human computer interaction specialists to make sure that this is intuitive, right? So you don't yell at the robot. There are lots of people who work to make these systems come together. And that's one of the things that I have a friend who's doing a PhD in the robotics area, and he says that's one of the things that is really cool about it, is all of the work that you get to collaborate on. So if you have interest in robots and applying them to other spaces, definitely we do have some stuff with that here. And I would recommend looking through the research that we have and look at the robotics-based courses that we have. We have a couple of faculty who do, robotics, and we also have some people who are normally in electrical engineering or mechanical engineering, but they also joint lecture for robotics courses. So those are also great opportunities. But I think that at least for the next 30 to 40 years, that's pretty much in the space we're heading, where a lot of applications of AI and primarily of AI will be in the robotics space, right? Which I would consider self-driving cars to be in, right? Which I would consider, medical robots to be in, right? Self-driving car companies raise billions of dollars without having ever sold a single car, right? Because that's how important this industry could be in the future. And so really it's now is a fantastic time, if you have interest in these stuff, to get involved, right? Start learning about things. So I want to hit on one more topic as well, that I think goes into stuff. It goes hand in hand with everything here as well, and that's human-computer interaction. So human-computer interaction is essentially studying how humans and computers interact and how you can make that interaction easier to achieve whatever set of goals you want. So I've taken a couple of courses in HCI. They're offered every so often. I don't know when the next offering is going to be. But let's see here. Yeah, okay, so here, for example, is CompSci 325, Introduction to Human-Computer Interaction, right? And so we can see here, right, that really a lot of the examples here of what you'll be doing is learning how to analyze how people interact with machines, and computers, not just robots, but also this 3D light switches, right? You can think of how many things are just poorly designed, they're engineered well in theory, but when you actually build and then market this thing, it doesn't actually work that well, right? Or it's difficult to use, even though that from an engineer's perspective, that would be fantastic, right? So an example, right, is
car stereos, right? In a car, right, from an engineer's perspective, right, you want the driver's seat and the front seat to be able to access the stereo system and like all the AC controls very easily, right? And that makes sense, right? And so you design it to just be straightforward, right? But from an HCI perspective, you would analyze this and you would consider, well, are we marketing this car to primarily people who would be driving alone? Is this like a commuter car? Or are we marketing this car as like a minivan towards people who typically will have people in the front seat with them, right? And in that case, that would help tell you whether you should angle your buttons towards the driver's seat or whether you should have them be straight on. And that's not something the engineer would consider, right? That's not really in like the problem description, but that is something that like, someone who is in HCI might consider, right? And that would definitely make the difference, right? Like if your angling was off then and you're trying to sit in the passenger seat and then control this AC system, but all the buttons aren't facing you, that would be a bit of an annoyance, right? So you have to consider like those trade-offs. And that's an example of what someone in HCI might think about. So if you have interest in like design or user experience or stuff like that, HCI is a great set of courses to look into. UX is becoming a bigger thing with like UI designers working hand in hand with UX designers, UI being user interface and UX being user experience. And so when you're not just developing robots or whatever, or cars or whatever, but you're also developing like websites that you want to be easy to navigate, or you want to develop online banking systems that shouldn't be super complex, but should also allow you to do, just enough to get the job done. And stuff like that is what user experience designers who would have HCI specialty would also, be working on. Okay. So that pretty much covers the content that I wanted to cover today. The last thing I'm going to do is basically just point out the relevant courses for these things. So for robotics, basically you have two spaces that you're potentially looking at. You can be going more towards the engineering route, which is where you're really looking at these sensors and whatever actuators, motors, how to actually build these things, right? What sorts of components you need, all the like physics necessary for that, right? That's more engineer based for like the actual hardware of the robot. And for that, you would be looking into, first computer systems principles being CS 230, right? And then you would probably go into the introduction to robotics course, right? Which would be about perception, mechanics, dynamics, and control. With whatever you take here, you want to make sure that science you take is going to be like physics based. That's probably going to be a good idea, right? You might want to be looking at like the inside the box. How do the computers work? Or maybe you look into mobile health sensing and analytics. So you look at like how sensors work, right? And then beyond that, it's going to be more applications based, and you're going to have to look into maybe embedded computer systems would be like a good class for that. But you would want to look into classes offered in like the electrical engineering department, right, as well. And we have these classes that are in very close relationships with ECE as well. So that's why they have courses on that list that count, that we looked at for the bachelor's degree that counts for CS credit. It's because a lot of the courses are like, technically they're offered there, but people who in CS also might want to learn about that. And then we also have a grad 603 robotics class. So I've heard it's quite difficult, a whole lot of work. As per say like game theory and AI, it's the same of what I had talked about last time with AI, where you want to take 240 and 220 or some similar thing for 220 or 230 because you want the programming background, and then 240 because you need the statistics and reasoning under uncertainty background. And then you would be able to jump straight to 383, which is artificial intelligence. And that's where you would cover your base, or further, into game theory. And 383 is really, it's all about how to formulate and solve search problems. And that's really the basis of AI. Then from there, You could go up to any of these applications classes that are going to use AI or machine learning or whatnot, but I would recommend probably going for 589. 589 being the sort of, master's introduction to machine learning, where you actually learn how to use things. So 589 is a lot more applicable. 689 is also machine learning, but it's a lot more theoretical, right? So they're essentially meant to be like two sides of the same coin, where 589 is like you learn how to do everything and you learn, a good bit about how it works. And 689 is like you build the things, like you learn how to build whatever frameworks instead of using existing ones. And then 683 is again super, it's a pretty intensive course, but it's basically like the next step above 383 that's going to be like classical artificial intelligence. And so if you're interested in like taking those, higher level courses, you definitely can. Just make sure that you're not bogging things down in the semesters, and talk to professors ahead of time to make sure that, your background with 383 is enough and, you're comfortable programming or whatever. Okay, so that's about all I have. Apologies for computer scuffed format, but I did get through everything I wanted to cover, so I think that's good. And I will upload this lecture. I have the next assignment that'll be coming out probably tomorrow morning. And it's going to be a bit shorter than what last week's is, but still similar vein to what previous assignments have been. Shouldn't take you more than like 15 to 20 minutes max. And I'll send an email when it's up. So it'll be just due next week. Right. So if anyone has any questions, I'll be around for a few minutes. Otherwise, I will see you all next Monday.
I had a quick question.
Yep.
So like, if we're applying for internships, like for summer 2021, and the deadlines are like maybe in the late October or early November period, is it okay if we use the resumes the same resumes that we submitted for assignment 2?
Yeah, definitely. I mean, you can use whichever you want. I tried to provide some feedback for each person's resume to help them structure things better, or what content they should look to add as they get it and whatever else. But that's sort of the purpose, is to try and help you guys build up these resumes. Now, if you're looking at applying to an internship now, if you want, you can iterate. I don't quite remember. I think yours was pretty good, but I don't quite remember 100% since I have a fair amount of people. So if you want to look over any feedback and then implement whatever you want and send me another copy of it, I can take a look before you apply to places and try to be more rigorous with it to make sure that it's like I'm looking at it from the perspective of someone actually looking to hire you for next summer, if you would like that.
Yeah, sure. Thanks. Thank you.